Okay, so picking up where we left off, I believe when we rotated the character in the last video, didn't notice, but he's now intersecting with the orb. If this isn't the case, then you don't have to do anything. So I'm just going to raise him a little bit, push him back, and then lower him again, making sure I'm not intersecting. And then just going to make sure it looks okay on the main camera. Yep, so he's kind of close to the bottom. You can move him forward a little bit and up a little bit because we don't, since the surface isn't truly smooth, we don't want the flat areas to actually strike him when they're moving past. So let's just see how that looks. Okay. So now what we're going to do is we're going to add the ability to jump. So we need to apply a rigid body to the player. So let's add component, physics, rigid body, don't use gravity, and I think everything else can stay the same as far as mass, drag, angular drag. Yeah, I believe that should do it. Let's run it now to make sure it didn't break anything. Let's go to window, scene, and then what you can do is you can just rotate the camera around to make sure, right, he's staying really close to the surface, so that should do. All right, so that fixes that little glitch. And so with the rigid body in place, we can now add velocity. So specifically, we're going to add vertical velocity so they jump, and then they land back down. So to do that, we're going to go to the HeroCon script. We're going to add a new key code up here. So public key code. We'll call this jump skill. Before we go any further, let's assign that because I have a way of forgetting to do that. So here we go. We'll make it the space bar. That's pretty typically jump in games. Okay, so if the space bar is being hit, you want something to happen. So in the update section, what you're going to do is this. You have to check for that input. So same structure input dot get key down and jump skill. All right, so if the jump skill button is pressed, what do we want? Well, we want them to jump, so we're going to add vertical velocity. So velocity along the y vector, the y axis. So get component, rigid body, as the component, velocity attribute, and since we're in a 3D environment, there are 3 vectors. Horizontal, no. Vertical, yes. How much? This is purely game balance as far as how fast and how high you want them to jump. We'll do 3 for the moment. And then 0 on the z-axis. So, that makes him jump in the air, but then it keeps going and going and going and going because gravity is not applied. So we need to we have to basically emulate gravity. So what we do is we say jump for a certain amount of time, and then we reverse this. We then say, okay, do a velocity -3 for exactly the same amount of time. Theoretically, they go up a distance and they come back down the exact distance. You can then, as a safety measure, you can then put in a statement that places it in an exact location just to make sure you don't have any kind of drift. So this makes it move vertically, but now, like I said, we want it to move after a period of time back down. So what we have to do is we have to add a coroutine called IEnumerator. And what we do is right here we say, okay, go run that coroutine. We can't do that yet because we have to write the coroutine first. So outside of update, outside of start, it needs to be all by itself. If you ever want to be certain, highlight the squiggly bracket. It will show you what bracket it matches up to. And something isn't right. What is... Oh, there we go. For some reason, I didn't think that bracket was highlighted. So you can see that this matches to this bracket. So by putting it here, you know it's outside of those brackets. So it's just IE numerator, no void. Whoops. Let's try that again. IE numerator and the name of what you want it to be called. So we'll call it stop jump with parentheses, squiggly brackets. You now have the basis of a coroutine. So yield, return, new. Now I try to explain every little line as far as what it means, or every word. In this case, just know that this line causes it to delay. That's really all that matters. So wait 4 seconds, measured in seconds. So let's say 1 second. So what happens is when we give the command to come here, it starts this timer. It's a 1 second timer. Once this timer ends, whatever's after this will then execute. Well, we already said what we want to have happen. We want this to get reversed. So since it was in the air for 1 second, going +3, we therefore want it to be in the air for 1 second, go -3, which means we put in another delay and another get component, this time at 0, 0, 0. So that was a little bit quick, but that's because you're really just using the same functionality. First, you add, you change the vertical velocity to +3. You wait a second. So it's been going +3 for 1 second. Therefore, you want it to go -3 for 1 second, and then you want it to go 0. Like I said, you can add an extra line here to make sure it gets placed at the right position. Basically, a failsafe that says, okay, now that the animation is done, or now that the movement is done, now reposition to a certain part just to make sure. We won't do that for the moment. We'll just run this, and I believe all that's left now is, like we said, this needs to refer to this. Now that it's been written, now we can say to go down there. So if the jump skill key has been pressed, apply this, and then start coroutine, parenthesis, and it was called what? Stop jump. There it is. All right. If I haven't made any mistakes, I believe that should make them jump. I don't see an error down there at the bottom yet. Now let's jump. Okay. Jumped way, way too long. Probably because how close it is to the camera, because the camera's right here. So might have to make some tweaks in the final game as far as his size versus the position of the camera, that kind of thing. I'm not going to worry about it right now. We can just make this smaller. If you like the speed, but don't like the distance, you could keep the speed the same, but then reduce the timer. 6 one way, 1/2 dozen the other. This actually reduces the speed, so I shouldn't say that. There is a difference. So he won't move as fast, so that could be a game balance issue. Yeah, I think the jump is just too long. 1 second just feels too long. So the speed seems okay, but that duration, let's make that like 0.5. And since it's a decimal, you got to put in the letter F, just like when you're doing vectors. The decimal confuses it. Okay, let's try this again. All right, that's pretty good. I like that. Now, there really isn't anything for them to jump over. We haven't added any obstacles, but that'd be next. The only collision detection we've done so far is really just the ring. The trees don't actually have any colliders yet, but maybe what we could do now is we could add like other obstacles, like maybe crates or something like that, or little tree stumps, something else that they need to jump over. So let's do that. Let's, for now, just use 3D object, cylinder, and we'll have it work as if it's a stump. So first, we're going to rotate the sphere. So let's rotate it. I just don't want the ring to be right there. Okay, so let's go to the cylinder. Let's rename it Stump. And we said we're going to put it again at the center. So the sphere again is, see, its position seems to drift a little bit. I'm not sure if it's because it's so large that when it rotates, its position changes. Maybe the center point isn't quite centered. But anyways, so we'll just use that rather than trying to figure out what's going on. And I spelled stump wrong. I put in the letter I. So here's the X. There is the Z. And now we just move it to the top. So now we've got a stump. By default, it's got a collider. Now, since the orb has a collider, I'm not sure if it's going to push out or not. Let's take a look to see how tall that is. So let's put that onto the sphere and see if this actually gets pushed out because of its size, of the collider rather. Yeah, it looks fairly tall. Let's confirm. Let's push way down and see if it's still that big. We could just shrink the cylinder. Nope, it's not getting pushed out. Okay, so now we have something for him to jump over. So the stump already has a collider. So if he collides with the stump, we want something to happen. So what we're going to do, some games, I think in the original Sonic, or should I say the original Sonic 3 that I'm modeling this after, I think if there's a single collision, you lost. So let's make it a trigger for now. And then what we're going to do is we're going to add a script to the player, not the stump, and see it and check for a collision. So we already have a script actually attached to the hero, so we can just repurpose this for the collision. So we need a collider section. So void on trigger enter, that should look familiar. Collider other. So if other dot name equals stump. For the moment, what we're going to do is we're just going to have the player get destroyed just to guarantee that this is working. I highly recommend that whenever you create a new collision, and I should have said this before, always test that collision as soon as possible before you start doing any kind of complex calculations or complex functionality. You want to know right away because, for instance, if there's a typo, this won't work. It won't understand what you're trying to do. This is case sensitive, so you have to use those capitals. So destroy game object. Now in this case, the script is attached to the hero, and so what's getting destroyed is the hero, not the other object. So always be mindful of what that is attached to the destroy. Okay, looks like he kind of drifted over it. Also, the collider might not come down far enough to hit the stump because the stump's traveling under him. So again, like I said, you want to test collision as soon as possible. So let's go ahead and just add, actually, probably the capsule collider. I really want to make it more elongated so it comes down. I'm not sure if I can really do that. So let's take a quick look. If I can't do it, I could just add a new collider. So there's the head. Actually, there's the sphere collider, not the capsule collider, sorry, sphere collider. And we're not really worried about anything bumping in the head, so we can actually lower this. So edit. Okay, so center. So it's Y, so it should be like -1. There we go. And now we can make this a little bit bigger again. And again, you got to be careful because now there's this area in front of him and behind him that would count as a collision. So that's kind of unforgiving. So ideally, you probably wouldn't use the Orb Collider, but again, we're just doing the basics for now. Again, just a proof of concept. So we want to make sure this collision works. It still didn't work. So stump. Name of the object is stump. There's the collider. Stump is a trigger. Void on trigger enter collider other. If other.name is equal to stump, destroy game object. So we know it's not colliding with stump. So let's do something. Maybe he's just above it. So let's take stump and we'll put it back to its original height and do this one last time. There we go. That's what it was. It was just going under it. So sorry, I'm not used to dealing with that kind of curvature. So the code was fine. The problem was that the object was just too low to be colliding with it. So it's just a matter of getting the right size for the collision to work, and then you can work on the jumping. So let's make sure the collision works again. It does. Now let's see if we can make the jump. And we jump. Nope, can't do it. It's a little bit of a nuisance because we adjust the size of the stump and we have to make sure that the collision works first before we can then test the jump. So, like I said, the stump is actually, the collider is actually curving out in front of him. Okay, so that was better because he did get over it before he collided. So now we can just tweak the jump itself. So we said that we don't want the jump to be more than half a second. It just looks wrong. So we'll increase the speed then. So 0.5 f, and then it has to be reversed to 1.5 f. So increase the speed by 50%, but the duration the same. There we go. He successfully jumped over the stump. So now we have the ability to have objects collide with him, okay? And it destroys him. So you could at that point then go to like a game over screen. And he has the ability to jump. So other than the fact that this uses really, really basic graphics, that's the basis of your game. You have this rotating world. You have obstacles that can beat the enemy. You have items that the enemy can pick up. Really, all that's left is replacing the placeholder graphics with the final graphics, and also if you want to do power-ups, like do you want him to run faster and things like that. So I think what I'll do is I'll probably end the tutorial here, and then I'll leave it up to you guys. If you guys say, hey, I want to see more stuff, show me how to do power-ups, show me how to do score, show me how to do a game over screen or a main menu, I can add that. But for now, I think that this really gets you really close to having the final product as far as the basic functionality, not the graphics, of course. But like I said, that was never the intention. The intention was the functionality, and now you've got the jump functionality, you've got the rotation functionality. You've got the not the power-ups, but you've got the beneficial items that you can pick up, such as rings. All right, so that should about do it.